Hello and welcome students to another video lesson. In today's class, we'll be discussing about the topic exponents and powers, and we'll see that what are the concepts that we have to learn in this topic. So hopefully at the end of this lesson, you will be able to understand these following concepts, that how we can define exponents, state the laws of exponents, then express numbers in the exponential form, and compare very large and very small numbers. So we can start with a very basic example to understand the basics regarding what do we understand about exponents and power. So for example, let's take a number over here. For example, 16 we are taking. So 16 we can write as 2 raised to the power 4. Okay. So 2 raised to the power 4, we can write it as 16, which is an equality. So this can be written as 2 raised to the power 4, we can write as 2 into 2 into 2 into 2. That is 4 times. If you are multiplying the same number with itself, okay, then we are getting 16 over here. So in this case, what we can see that 2 raised to the power 4, it is not 24. 2 raised to the power 4 here, 2 is the base, right? So 2 is the base and 4 is the index, or we can say the power of 2. So when 2 is multiplied by itself 4 times, okay, it gives 16. So this form of expressing is called as exponential form for expressing any number, okay? Similarly, for example, if 2 is multiplied m times, or we can say 2 raised to the power m, right? So if you are multiplying 2 into 2 into 2, so on up to n times, so that particular number we can express as 2 raised to the power m, okay? So in that case, 2 will be the base and m will be the index, okay? So this m or index can be also known as, we can also call it as exponent or power of the base. So in this case, 2 raised to the power m, where 2 is the base, and m can be known as, can be called as exponent or power or index, right? So let's take a few more examples regarding this. For example, if you are writing 2 raised to the power 2, okay, so in that case, we can easily express it at 2 into 2, okay, that's equals to 4. So next up, we can see that the next example is 2 raised to the power minus 2, okay? So that's comes under the concept of powers with negative integer. So if it is a positive integer, for example, 2 raised to the power 3, then in that case, we'll get 2 into 2 into 2. That's equals to 8. We have discussed it previously also. So, but now what we can see over here that if the power is raised to a negative integer, so powers with negative exponents. So in the second example, what we can observe is that 2 raised to the power negative 2, that can be written as 1 upon 2 into 2, okay? That can be written as further 1 upon 2 raised to the power 2, and that's equals to 1 upon 4. Similarly, in general form, if any number, okay, or if any base is having a power with negative exponent, okay, for example, a raised to the power negative of n, then that power will will become positive when it comes in denominator, okay? So similarly, a raised to the power negative of n can be written as 1 upon a raised to the power n, where n is a positive integer. Next up, the example is 5 raised to the power negative 3. It can be written as 1 upon 5 into 5 into 5. That's equals to 1 upon 5 raised to the power 3, and which is equals to 1 upon 125. So in this way, we can represent the exponent forms of a base which is having a negative power, okay? Similarly, 10 raised to the power 1 can be written as 1 upon 10, and 10 raised to the power negative 2, that's equals to 1 upon 10 into 10, that's equals to 1 upon 100, or 1 upon 10 raised to the power 2. So in this way, we have to represent the powers with negative exponents, okay, in the denominator, with having 1 in the numerator. Similarly, the next example is 5 raised to the power 4. We can write it as 5 into 5 into 5 into 5. That is equals to 625, right? So similarly, if it is given 5 raised to the power 3, we can easily multiply it 3 times the same number. We'll get 125. And 125 can be further represented as 625 by 5. Okay. So now let's check with a few more examples for negative powers. So based on this pattern, what we can write it as that 5 raised to the power 2 can be represented as 25 or 125 by 5. Similarly, 5 raised to the power 1 is nothing but 5. That's equals to 25 by 5. And 5 raised to the power 0 is 1, because any number or any base having a power 0, that will be always 1. So in that case, we can represent it as 5 by 5. Okay. So the previous number is divided by the base 5. So from the above pattern, what we can observe over here is that 5 raised to the power -1 can be represented as 1 by 5. Okay, similarly, 5 raised to the power -2 can be represented as 1 by 5 further divided by 5. Okay, that can be written as 1 upon 5 into 5. That's equals to 1 upon 5 square. So final result, what we are getting from here, that 5 raised to the power -3 can be further represented as 1 upon 5 into 5 into 5. That's equals to 1 upon 5 cube, and that is nothing but 1 upon 125, right? So in this way, we can represent the powers with negative exponents. I think this much examples are enough. So in general, what we can conclude that we can say that for any non-zero integer if a raised to the power -m, then it can be written as 1 upon a to the power m, where m is a positive integer now, and a raised to the power -m is the multiplicative inverse of 1 uh, multiplicative inverse of a to the power m. What does it mean? That if you will multiply a raised to the power -n into a raised to the power m, you will get always 1. Okay. Similarly, if you are multiplying 5 into 5 raised to the power -1, then you will get 5 into 1 by 5. That is nothing but 1. So this was the concept of multiplicative inverse and how we can represent a non-zero integer a having a negative exponential power. So let's move to our next concept, which is laws of exponents. So first law, you can easily observe over here that if a is any real number and m and n are positive integers, then what we can represent, a raised to the power m into a raised to the power n can be written as a raised to the power m plus n. Okay, very important law, you have to memorize it. And we can see a few examples based on this. The first one is 5 raised to the power 4 into 5 raised to the power 2 equals to 5 raised to the power 4 plus 2. That's equals to 5 raised to the power 6. So one thing you have to keep in mind that the base should be same. Okay. So as you can see that the base in the example is same as 5. If the base is different, then we cannot apply this law, right? So the base should be same. So the value of a should be same, and the value of m and n may differ. Okay, so as you can see clearly in the example, 5 raised to the power 4 into 5 raised to the power 2, we are just getting the base as 5 and the power are added with each other. Okay, 4 plus 2 will get 6. Similarly, next example is 2 by 7. So the base can be in fractions also, as you can observe it over here. So let's see if you are able to solve it or not. So as you can see clearly over here that on the first side, the base we are having a as 2 by 7 raised to the power 7. Okay, but we are multiplying with a different base, that is 2 by 5. So clearly the base is different over here. So we cannot apply the first law, right? Instead, if it is 2 by 7, 2 by 7, okay, over here also and over here also, in that case, we can apply the first law. So answer will be 2 by 7 into 7 plus 2, that is 9. So answer will be 2 by 7 raised to the power 9. But in this case, we cannot directly apply the first law because the base are different, okay? So that you have to keep in mind. Then second law, let's move to second law, in which says that if a is a non-zero real number and m and n are positive integers, then a raised to the power m divided by a raised to the power n is equals to a raised to the power m minus n. So a little bit similar with the previous one. In the previous law, we were multiplying the two exponential numbers, okay? But in this case, we are dividing. And one thing you have to keep sure that the bases should be same in this case also. The value of a cannot differ. Okay, so if it is written like that, a raised to the power m divided by a raised to the power n, then we can write it as a raised to the power m minus n. For example, 5 raised to the power 8 divided by 5 raised to the power 3. So we can write it as 5 raised to the power 8 minus 3. So answer will be 5 cube, that is 125. So in this way, we can easily apply the second law for any two exponential numbers which are written in numerator and denominator form, then we can clearly write it as like this. Similarly, second example, well, if you can check, the bases are in fraction, but both the bases are same. So we can clearly apply the second law. So in that case, we can write it as 3 by 5 raised to the power 5 minus 2. Okay. So our solution will be 3 by 5 raised to the power 5 by minus 2, that is 3. So that is 3 cube by 5 cube. Okay, or we can write 3 by 5 whole cube. So let's discuss the next law, that is third law. So in third law says that if a is any real number and m and n are positive integers, then what we can write, a raised to the power m whole raised to the power n can be written as a raised to the power m into n. So we can multiply the powers if it is written like that, or we can write it as a raised to the power m and whole raised to the power m. Okay, so similarly, the example we can observe over here that it is written as 5 raised to the power 2, then whole raised to the power 3 can be written as 5 raised to the power 2 into 3. That is nothing but 5 raised to the power 6. Okay, that is our final answer. Then next example is evaluate 2 by 5 raised to the power 4 whole raised to the power 3. So we can easily multiply the powers. Okay, so 2 raised to the power 5 into 4 into 3, that is equal to 2 by 5 raised to the power 12. That's our final answer using third law of exponent. Now let's move to the fourth law of exponent, which says that if a and b are any real numbers and m is any positive integer, then a raised to the power m into b raised to the power m is equals to ab raised to the power m. Okay. So if powers are same for both the bases and bases are different, then we can write it like this. For example, 6 raised to the power 4, we can split it as, because 6 we know that can be written as 2 into 3. So it can be written as 2 into 3 raised to the power 4. And now we can distribute the exponent separately for 2 and 3. So it can be written as 2 raised to the power 4 into 3 raised to the power 4. So if bases are different but exponents are same, then we can combine the bases, we can multiply them, and same power will be there on the resulting base, that is 6 raised to the power 4 in that case. Similarly, one more example, simplify 2 by 3 raised to the power 3. So how we can write it as, we can distribute the power in numerator as well as denominator. So we can write it as 2 raised to the power 3 plus divide by 3 raised to the power 3. Okay, so 2 cube is 8 and 3 cube is 27. So our final answer will be 8 by 27 using the fourth law. Let's discuss the fifth law now. So in fifth law says that if a and b are real numbers and m is positive integer, then a raised to the power m by b raised to the power m is equals to a by b raised to the power m. Okay, that's all about the fourth law, for fifth law, sorry. And the example is, for example, if you have to evaluate 2 by 5 raised to the power 3, the same example we have seen previously also. So it can be written as 2 cube by 5 cube, that's equals to 8 by 125. That's our final result using the fifth law. Then last one, the last law is sixth law, which says that if a is any real number, then a raised to the power 0 is equals to 1. So for any real number, if the exponent or the power or the index is 0, then the result will be always 1. Okay, so now the laws are over. We'll discuss a few examples based on these laws, and all of you can just pause the video and try to solve these examples on your own and check the solutions further. Okay, so for example, the first one is 4 raised to the power minus 2. So we can easily write it as 1 upon 4 raised to the power 2. So answer will be 1 upon 16. Okay, that was quite easy. Now, second one is also based on the negative exponents. So 1 upon 8 raised to the power negative 2. So if the negative exponent is in denominator, then if you are converting the negative exponent into positive, so it will automatically come into numerator. Okay, so 1 upon 8 raised to the power negative 2 can be written as 8 square or 8 raised to the power 2, and which can be further written as 8 into 8, that's equals to 64. So these two concepts you have to remember. It's been widely used, okay, throughout in various departments. So you have to just get it clearly that how we are converting this negative powers, okay, into positive. Next example is simplify This is the first question. Negative 6 raised to the power 5 into negative 6 raised to the power negative 10. So clearly, what we can observe from the first example that the base is same. So if the base is same, which is negative 6, then we can apply the first law in which we have to add the powers. So it can be written as negative 6 raised to the power 5 minus 10. Okay, using the first law. So final answer you will get negative 6 raised to the power negative 5. Okay, that's our final answer for the first one. Now second one also, you can see that in that case also we have to apply the second law for exponent, in which we are having same base. And for the first question further we can simplify it as, because the power is negative, so we can write it in denominator form using the law of for negative exponents. So negative 6 raised to the power negative 5 can be further written as 1 upon negative 6 raised to the power 5. Okay, it is not negative 5 over here, it's 5. Okay, so you have to make it clear. Using this law we are making. Now let's move to the second one, in which uh, the base is 8. So 8 raised to the power 5 divided by 8 raised to the power negative 6 can be written as 8 raised to the power 5 minus 6. Okay, because we have to subtract the power. So using the second law, that a raised to the power m by a raised to the power n can be written as a raised to the power m minus n. So 5 minus 6. Okay, in that case what you will get, 5 minus 6. So final answer, you will get 5 minus 6. So minus becomes plus. Here one minus sign is missing, so you have to put it on. So we'll get 8 raised to the power 11. Okay, that's our final answer for this one, because minus becomes plus. So you have to put just one minus sign over here. I hope it's quite clear to all of you now. One more example, we can see that such type of questions may appear, okay, for you. So in this case we have to find the value of m such that the expression is given as negative 5 raised to the power m plus 2 into negative 5 raised to the power 8 is equals to negative 5 raised to the power 9. So on the left hand side what we can observe, that the base is same, so we can add the powers clearly. So it can be written as negative 5 raised to the power m plus 2 plus 8. So it becomes m plus 10 is equals to negative 5 raised to the power 9. Okay, so you can clearly see that on both sides of this equation the bases are same. So this law you have to keep in mind, that if the bases are same on both sides of an equation, then we can equate the powers also. Okay, so by equating the exponents we'll equate the powers now. So m plus 10, that is equal to 9. And now by transposing 9 on the left hand side or transposing 10 on the right hand side, we'll get our final value, that m is equals to 9 minus 10, which is equals to negative 1. Okay, so this rule you have to keep in mind, that if bases are same on both sides of the equation, then we can easily equate the powers. Okay, so these were the few examples regarding the laws of the exponent, and further we'll discuss more in our online sessions. So now let's move to the next concept, which is regarding comparing very large and very small quantities, small numbers. For example, the radius of earth is 6.37 into 10 raised to the power 6, and the radius of moon is 1.74 into 10 raised to the power 6. So what the question is, that we have to compare the diameters of earth with the diameter of moon. So first of all, we have to find the diameter of earth. So we'll double the radius, because diameter is equals to twice of radius. So diameter of earth becomes is 12.74 into 10 raised to the power 6 meters. Similarly, if you will double the radius of moon, we'll get the diameter of moon, that's equals to 3.48 into 10 raised to the power 6, right? So just we have to multiply the radius with 2 to get the diameters. Now the comparison we can easily find by finding the ratio. Okay, so here you can see that the dia of earth is quite bigger than the dia of moon, so we have to keep it in numerator. So 12.74 into 10 raised to the power 6 meters, that is in numerator, and in denominator we have to put the dia of the moon. So when you will cancel out, after further simplification, you will get the final result as 3.66 meters. Okay, so what we can conclude from this observation and this result and this calculation is that we can write the final statement that the diameter of moon is about 3.66 times the diameter of the earth, right? Next, we can see the comparison between Sun and Earth. For example, the distance between Sun and Earth is 1.496 into 10 raised to the power 11 meters, and the distance between Earth and Jupiter is 6.290 into 10 raised to the power 11 meters. So, if I'll ask you one question over here that find the distance between Sun and Jupiter, then nothing we have to do. We have to just add these two given distances. So we'll get 6.290 plus 1.496 because the exponential power is same. So we can take it as common. So final result we'll get after the summation of this. Okay. So in this way, we can compare a very large and very small number. So final result, the distance between Sun and Jupiter, we got 7.786 into 10 raised to the power 11 meters, right? So uh, that's it for this type of questions. Then, for example, let's take few more questions over here, and this will be your home assignment to try to solve these questions. And in our second exercise also, we'll try to solve it, such type of questions. So, for example, the mass of Earth is given as 5.97 into 10 raised to the power 24 kgs, and mass of Venus, okay, that's given as 4.86900 into 10 raised to the power 24 kgs. So, what is the total mass? So, nothing you have to do, just you have to add these two given masses for Earth and Venus respectively, right? And one more observation, one more calculation you can make from here, that mass of Earth is given as 5.97 into 10 to the power 24 kg, and mass of Jupiter is given to you as you can see on the screen. So you have to find the total mass in that case also. So this was all about the concepts related to this chapter, that is exponent and powers. So we'll quickly summarize that what we have learned in this chapter. So for example, if 2 raised to the power m, then it means that 2 is multiplied by m times. So this form is called as exponential form, right? Of a given of a given number. Then the laws of exponents we have learned today. The first one is a raised to the power m into a raised to the power n. That's equals to a raised to the power m plus n. Okay. Then this is the second law. A raised to the power m divided by a raised to the power n. That's equals to a raised to the power m minus n. Third law, a raised to the power m whole raised to the power n, that's equals to a raised to the power m into n. Then fourth law, a raised to the power m multiplied by b raised to the power m. Then we can write it as ab raised to the power m into n. Then final is a raised to the power 0 can be written as 1. Okay, it's always 1 for any base which is having exponent 0. So it is always 1. Then last one is a raised to the power m by b raised to the power m, that is equals to a by b whole raised to the power m. Okay. So students, that's all for this session. I hope you understood the concept related to this chapter, and let's meet in another interesting video class. So till that time, take care, and that's all from my side. Assalamu alaikum to all of you.